Hi guys, welcome. We're going to watch a video lecture, or this is your video lecture for your doodle notes on the periodic table of elements. A lot of this stuff we have already talked about before, so we are just relearning what we've already learned and putting it in a easier to study way. So we know that a row on the periodic table is called a period. We've got an example of a row right here, a part of a row: boron, carbon, nitrogen, oxygen, fluorine. You'd find that they're all in row, I don't have a periodic table in front of me right now, but I think it is row 3. They're all in row 3. We call those periods. One of your goals is to be able to identify the period and row of a given element. We practiced that yesterday. We'll keep practicing that as well today. We know that a column in the periodic table is called a group. Now, rows, they mean something, but that's something we don't need to talk about for 8th grade science. But a group is really important because all of the elements in the group have the same number of valence electrons. And we learned yesterday that it's the number of valence electrons, or the electrons in the outer shell, that enable an atom or an element to be reactive. So the helium, neon, argon, krypton, and xenon are in group 18, which we know to be the noble gases group, and that means that they're not very reactive. That's because they all have, except for helium who has 2, they all have a full outer shell with 8 electrons in it. They don't need to borrow or steal or give away an electron in order to be happy. So remember, our group determines our reactivity. So generally, atoms in the same group are going to react the same. If one atom catches fire when it's exposed to oxygen, another atom of the same group will probably also catch fire when exposed to oxygen. That's one of the things that Mendeleev helped. Those chemical properties are what helped him create his periodic table. So that's what we use today, and it makes a lot of sense too. There are 18 groups in the periodic table. Group 18 can also be called group 0, but we will call it group 18. We've already talked about a lot of these groups before, but we're going to go over it again one more time. Group number 1, do we remember our special name for group number 1? We should have written it down yesterday in our periodic table, or Monday in our video lecture, or our video, the crash course video. Group number 1 are called the alkali metals. They're soft, they're shiny, and they are very, 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 very reactive. They have 1 valence electron. They will form a positive 1 ion. We don't necessarily need to know what an ion is, but if you would like to know, an ion forms. It can be positive or negative. If it is a positive ion, that means it gave away that 1 electron. And they are generally found as compounds because they are so reactive. We won't really find pure sodium out in the environment. It'll typically be bonded with something else. We won't usually find pure potassium out in the environment. It'll usually be bonded with something else because they are so reactive. That is because they only have 1 valence electron. If you will, on the bottom of your notes, shade in, or you can use the drawing feature of Google Slides to color in this group 1 right here on our example periodic table. Also, don't forget that our metals are on the left-hand-ish side and our non-metals are in the right-hand-ish side. We know that these shaded ones right here are metalloids. You don't need to shade in the metalloids. Metalloids, again, are elements whose properties are in between those of metals and non-metals. They can have properties of both. Group number 2, what did we call those? Do you remember? Hopefully you can identify these as alkaline earth metals. They have 2 valence electrons and they form a positive 2 ion. That means that they give away both of those electrons, so they have a positive charge on them. They are semi-reactive. They're a little bit reactive, but not as much as our alkali metals or group 1 metals. Now you're going to shade in the group 2 right here, whatever color you decided to color it in. You'll shade it in, or you will use the drawing feature again to put a rectangle of a different color right here. Our next groups in our periodic table are 3 through 12. We know those as the transition metals. They are less reactive. That's why you can hold a copper penny and it doesn't explode in your hand. Or we can use the copper metals for wiring. They don't, they're usually pretty good conductors of electricity. They don't explode. They can form multiple types of ions, so they could form positive ions or negative ions. It just depends on what element you're talking about. They have high melting points and high boiling points. That means it takes a lot of energy, heat energy, to make this metal go from a solid to a liquid. Some of our transition metals include like iron, copper, cobalt, nickel, silver, gold, titanium. All of, when you think traditionally metals, those are our metals. You're going to shade those or color those in your little periodic table down here with the color that you used. And then group 17, we know those as, drumroll please, halogens. They react with metals to form salts, like we know that our table salt, the chemical formula is NaCl. That is sodium plus chlorine. Chlorine is one of our halogens, so is fluorine, iodine, boron, borine, and a couple others too. They form acids when bonded with hydrogen, like HCl is a really, really, really strong acid. It dissolves everything but plastic and can eat through your skin. It's nasty stuff. You don't really want to mess with that, but it is really, really acidic. Halogens are also really reactive. I know that's not written here on the board, or on the screen, because they're only lacking, their valence electron number is 7. So because they're only lacking 1 electron, they're readily able to bond with other things so that they can have their valence, or that last shell, filled. You're going to shade group 17 in here with the color that you used to write in. And then group 18, our last group we're going to talk about today, we know those as the noble gases. They exist as a single atom because they're unreactive. Their valence shells are full, so they don't need any more, so they don't react or bond with other elements. That's what this means. 8 valence, V electrons, E negative. They have a full shell. They don't need to react. Fun fact that we learned in Crash Course, Mendeleev didn't discover these or didn't know about these because they only studied reactive elements. These were added on later. You're going to shade those in your PowerPoint or in your notes. That's actually the end of the notes today. It's a really short one. A lot of it's review from what we've already learned and kind of putting all of those properties into one place. Have a great day, guys. If you have questions, email me.